Hey guys, how's it going? This will be my first hardware unboxing video I've done in quite a while, and it'll be a nice little auspicious occasion. We've acquired the Zotac Amp Extreme Edition Infinity RTX 5090 card from Newegg.com. So give me 1 second here and I'll go ahead and open up the box and we'll get a look at this thing and we'll get it installed and play around with it a little bit this evening. So stand by 1 moment. Alright, so we can see our box here from Zotac. Say this is the Amp Extreme Infinity, 32 gigs of GDDR7 memory. This is like an Ice Storm 3.0, whatever that means, something to do with their cooling. Dual BIOS, Freeze Tech. I think it's funny, Freeze Tech paired with Firestorm. It seems like that would cancel each other out. But anyways, so this is part of the new NVIDIA RTX 5090 launch. This has used the Blackwell GPU architecture, previous generation being Ada Lovelace, before that being Ampere, and so on and so forth, back many generations. But anyways, comes in kind of a nice box with a little carrying handle. I haven't seen anything like that in a while. That was sort of something they used to do with GPUs a lot, is they'd come in like a carrying case kind of thing. And so yeah, the Ice Storm is GPU cooling. Spectre 2.0 is dynamic RGB lighting, which, as you can see on the card picture, they have some different lighting zones. I've already downloaded their software onto my PC, so once I get this installed, I can install that software and we can try to play with the lighting and see if it works or not. So that'll be fun. Firestorm is, yeah, like that's their software. It's kind of like EVGA's old. Oh god, I forget the name of it now. That feels stupid, but basically, it's like MSI Afterburner. It's like a GPU control software. Dual BIOS, so you can have a quieter mode or a performance mode. Blade Link refers to their fans. Active fan control 2.0. Different RPMs for each fan, so that's cool. And it's got 3 big old fans on it. But this supports the new DLS 4.0. Has some multi-frame generation technologies and so forth for playing games. You can use the new what they call like the Transformer model for DLSS 4 and actually use DLSS on some older games that don't even normally support DLSS, or at least didn't support DLSS 4. They were supporting DLSS like 3 or 3.5, but you can kind of use like a beta version of the DLSS 4.0 frame generation on games like Witcher 3, for example, I believe. So I'm going to go ahead and get this box opened up. We'll see what comes with it, see how big the card is. The whole box is like 9.8 pounds. This has got to be a very heavy card, I imagine. It's like 3.5 to 3.75 slots, I think, total for the cooler. That's going to be interesting. That's a very big card compared to what I've had on my machine downstairs. So give me a second here. We'll get it opened up. We'll have a look at the card, kind of see what different connectors it has and where we're going to hook it up at, and then we'll get it in my system. So give me 1 moment. Alright, so I got kind of the outer sleeve off there, and you can see it's sort of like a briefcase almost, but it's really pretty heavy to work with one hand. Let's see. Okay, so we've got, yeah, this is kind of awkward to do with one hand. Try not to tear up the box in case, hopefully I don't send this thing back. If you guys have watched the Gamer's Nexus review on this card, you'll know that, or not this specific card, but on the RTX 5090s in general, you'll know that some of these cards are missing some ROPs, and so I'm hoping, like rasterization, I forget what it stands for, I'm terrible at remembering acronyms, but rasterization units, processing units, to gaming and beyond. I don't know what's in that. We'll open that here in a minute. Some kind of little sleeve or envelope. Okay, open this up here. Wow, that is really big. Okay, let's see what we got here. So this is what looks like it to be a GPU brace. I guarantee this card is very heavy. I don't know if this is gonna, I'm not sure how I would utilize that specifically. Okay, it goes like this, like the feet go down, and then you've got kind of like a lift for it. But the way my case is set up, I don't think I've ever been able to use these things because they're not tall enough. Like the case is too big. I don't have like a mid tower. I don't think you could fit this card in a mid tower, so I don't know what good this little thing does. It's not tall enough, I don't think, for most cases. Okay, so this is, excuse me, this is our power connector. So this converts 4 8-pin PCI Express power connections into a single, how many pins are there? 2, 4, 6, 8, 10, 12 pin. And this is an ATX I know people have been saying 5.0, but I believe it's ATX 3.0. The card generation is PCX 5.0. I may be wrong, but whatever. This should be ATX 3.0 power connection that can deliver up to 600 watts. These cards can use up to 570 watts or 575 watts, to my understanding. This specific one may use more than that. I'll have to figure out if that's the case or not. I know that, like, the Founders Edition and the general spec for the 5090s is up to, again, 575 watts. I don't know what is in this. Let's see if I can just rip that thing open. Some little cable. Okay, so this is for RGB lighting. So you can actually run it off your board, I think. Yeah, because it's got an RGB, an ARGB header that's for addressable RGB, and this probably plugs into the card somewhere, and then you can run it off of, like, your motherboard software. I don't use any of that kind of stuff, so hopefully I can just control this from within, or maybe you still have to do that and then run it from Zotac software. I'll have to find out. Like, their Firestorm program should have their RGB options built in. So that was it for, like, the little accessories and stuff. But man, that thing is ridiculous. Ridiculous. Oh my god. All right, I'm gonna set this off for a second and see if there's anything else in the box before I continue. That is physically demanding. I don't think there's anything else in there. It doesn't look like it. No, I don't think so. All right, let me throw that in there. So I don't think I'm going to be able to use their brace. I'll try. I think I might have to get a taller one. I might have something laying around here I can use with it. Give me a second. I want to see what is in this envelope, and I can't do that with one hand, so stand by. All right, so the envelope had some instructions basically. There's like a manual, something that tells you how to use the little GPU mounting brace that we were talking about. And then there's like a little character. It looks like a card that you can stand up, maybe. Yeah, it's like a little stand-up thingy. I'm not gonna mess with it right now, but it's like a little, some kind of a like a mascot for Zotac, I guess. I'm not as familiar with some of their stuff as I am with other brands. And then we've got more, probably warranty information and more manual kind of stuff for whatever you're going to need to know if you had to return it or contact them for warranty service. So I'm going to leave that stuff in the box. I am going to keep out our adapter because I'll need that. May end up plugging this into the board, may not. Again, I don't use any kind of RGB software. I'd rather not have to screw with that, but that is something I may have to do. So give me 1 minute. I'm going to get this card out of the bag. I know I'm going to need 2 hands for that, so 1 moment. Alright guys, this thing is very, very physically large. It's not quite as big as I thought. I thought it would be more like 3.5 to closer to 4. I think it's pretty much right at 3 slots. Maybe a hair long, you can see the cooler just extends a little bit beyond the mounting bracket, but pretty much what I was thinking. It looks like, as I was thinking, it has a single HDMI, I think it's 2.1B. We've got several DisplayPort 2.0s, I think the 2.0 generation display ports. So they can do like 8K at 60 hertz, I believe. They might be able to do 8K 120 now. I'd have to verify that, so I'm not going to tell you I know that for sure. But I like the color scheme of this. It's kind of a gray and gold, which sort of matches what I've been doing because I've been using the NVIDIA data center cards like the RTX 5000 ADA generation, for example, kind of has this color scheme, and I've sort of grown to like it. It's a dark gray or black with kind of a golden tone to it. So we've got kind of gold fan, the Zotac emblems on there. So Zotac on the center one, and then they've got their V again, kind of on the edge. Now we've got, let me turn this thing over here. We've got some different things. So this is where obviously the RGB connection is going to go, like we were talking about. So that clearly is meant to plug in there. And then from that you could run it to your motherboard. I think that is sort of a really, I don't know how long this cable is. I feel like that's a dumb place for that. I think the end of the card would have been better or something. Maybe I'm wrong, but it just seems like invariably it's going to drape over the card, or you're going to have to go up this way with it. Depending on where your motherboard, ARGB connector is at, that may not be a particularly good place for this to be. I guess they had to put it somewhere, and they just figured they'd put it next to the power connection. I just think that I don't know. Plus, it's the white cable I don't really care for. I think the white should be somehow matching. It should be black. It should be a black cable, and with a black connector. That's just an aesthetic gripe, but just mentioning it. I do like the look of the card otherwise, though. So they've got some plastic on here. It says remove before use. I'll have to remember to do that. We have our PCI Express, excuse me, not PCI Express, the ATX 3.0 power connector, and again to deliver up to 600 watts of power. And then you can, I think you get, what is it, 75 or something watts over the PCI Express connection. So the card can actually get over that 600 watts if it can actually be set to use that. I don't know how far a clock like this can be a card like this could be overclocked, but you probably could use well in excess of 600 watts with this card. That's a lot. I don't plan to use that much if I can help it. I might overclock it occasionally, I guess. So like I say, we've got a little dual BIOS switch here, I imagine, switching between silent performance mode. How much of a difference that really makes, I don't know, especially if you're going to control it from within software. Back of the card has the Zotac logo. Again, I think that's plastic. Yeah, it's not metal. That's too bad. But it's already so heavy. Like, I mean, most of the material is very sturdy feeling. It looks like a nice quality card to me. You know, just from a quick glance at it. You got the rear end of it with like their infinity mirror. It doesn't look like anything right now, but I think as we saw in the images, that can light up and says probably Zotac, and maybe you can get it to display some custom images. I don't fully know yet if that's a possibility. Very thick heatsink material. Obviously that is metal. Okay, so I'm going to go ahead and pull off the little sticky pieces here. Not sure where to put that. I guess I'll just put that off the side somewhere. And I'm going to have to get this kind of shrink plastic stuff off of here, and then we can try to hook it up. I think what I'll do next after this is I have to go shut my system down, and I have to pull the card out of that system. That one is going to go back upstairs with my Threadripper with its counterpart. I have two of those RTX 5000 ADA edition cards, and they can work together in DeepFace Lab to give me 64 gigs of VRAM. I'm going to do that and try to train some even higher res models than I've been doing, and then this will go in the system in the living room. Part of what I've been missing using data center cards is native HDMI. I have to use like a DisplayPort to HDMI adapter, and for some reason that scales the desktop a little funny on a television set, and it's never worked quite right. And you get some jankiness, like you'll turn on the TV and sometimes you'll get no signal. You have to turn it off and on again, or actually unplug and then reconnect your HDMI, for example, from the adapter to get it to kick back on. So having something with native HDMI again will be nice. That's partly why I want to use it in my living room. So give me 1 minute. I'm going to get this plastic off here. I don't think I can do that with one hand, unfortunately. Tell you what. Oh. All right, give me 1 second. We'll try to get this off here. All right, here we go. Remove before use. Yes, oh. I'm trying to knock this thing over and damage a freaking $2,700 video card. After taxes, I think it was like $2,650. And I had to buy a monitor with it because it was a combo deal. Because Newegg likes to force you to buy other stuff that you don't necessarily want. But it's a nice monitor, and I can sell one of my other ones and make up for it, so whatever. But it's annoying. Okay, so the plastic has been removed. Is there any on? I don't feel any plastic on the little... Sometimes they'll have plastic on the fans, like on the little emblems in the center. I keep accidentally catching these. I'm just going to take these off. These are little protective covers for like HDMI and DisplayPort. But it seems like it's very easy to bump them on this, and they just come out. So see the little cover for... or I/O. So that's been removed. Plastic, I believe, is 100% been removed. That's a really nice... I like the way this card looks, honestly. I haven't had too many Zotac products. I had one of their 2080 Ti's years ago, and it actually was pretty good and lasted a while. But anyways, done unboxing. I'm going to go pull my card out of my system. I'll be back. We'll compare them real quick, and then I'll put this in, and we'll start playing with it. All right, so we've got both cards out next to one another. So this is the RTX 5000 ADA generation card. So when it says 5000, it doesn't really mean this is a 5090. This is not from the same generation. This is like the equivalent of a RTX 4080, maybe a 4080 Super, but it has 32 gigs of GDDR6 memory. And this is a data center card. So you can see it has the blower fan style. It's just designed to blow heat out the back end of the card. And its power connection is only using 2 8-pins to an ATX 3.0 connector. These cards use, I think, 225 to maybe 240 watts maxed out. It's not as fast as a 4090, but it had way more memory, and I was able to use it to do higher resolution models, like I've been doing 448 resolution AMP models using this card. This card will not allow me to train anything higher resolution than this did because it also has 32 gigs, but it is faster in memory. It's GDDR7 versus GDDR6. This is almost a 600 watt card versus the 225 watt card, so it uses sort of roughly 2.5 to 2 3/4 the amount of wattage compared to this one. So it's using a lot more power. It has probably much higher clocks. In fact, I know it has higher clocks. It's a totally different, faster, more recent architecture. This is a couple years old, but these are nice to have because a couple of them still use less power than one of these does. And for deepfakes, for games, you could never use 2 cards and get 2 times the VRAM. But for deepfaking, machine learning applications, at least Deepface Lab can utilize 2 of these, and it will use all the VRAM. And so I've tested that. You can go ahead and have these being dual. You know, if I put 2 of these in one system, which I did before and I will do again, I'll put this back up with the other one. I have a second of the same card with my Threadripper 7960X upstairs. I will then have 64 gigs of VRAM to play with. I can go above 448 resolution models. I'd like to see if I can do 640, which is as high as Deepface Lab will let you go. We'll see if I can do that or if I'll still run on a VRAM. It's surprising how fast you can run on the VRAM, even with a card with 32 gigs of memory, or even twice that. But you can see, like I said, we've got a little power connection on the side here. It's the same as the one that was over on the other side there, but it's the ATX 3.0 power supply, or power connection, excuse me. But again, with this card, it doesn't use nearly as much. Ergo, it's only converting 2 of the 8 pins instead of 4 of the 8 pins. This has 4 DisplayPort only. It does not have HDMI. So using it on a television set, I was having to use this adapter, and I've tried different adapters. This is supposed to be an active adapter. Back in the day, you actually used to have to plug these in with like a power supply. They would have like they'd made a much bigger head on it, and it would have a power connection that you plug into USB, or even have to plug into the wall with like an AC adapter to give it enough power to actively convert the signal. But this is supposed to be an active connection. It does do 4K 120 hertz, but it's like a little less than 4K. It's like 3700 something by like 2000 something. It's like you have to rescale the desktop because it won't scale properly over from DisplayPort to HDMI. I don't know what it is with televisions. It probably works fine on a monitor, although monitors have DisplayPort and you wouldn't need to do that. But anyways, that's the 2 different cards that I was going to show you guys here. Like I said, I also have another one of these upstairs, and I have an AMD W7800 Pro, which is also a 32 gig card, but AMD sucks for training deepfakes. I am using it because I got it. When I say cheap, it was like cheaper than these, but it was still an expensive card. That said, it's enough, again, with the VRAM to train high-res models, but I want to go further than that, which is why I want to put this back with its brother. And then this one I can play games as well as, of course, still train everything I was at least doing with this. So I can still do high-res, relatively high-res models with it, like I say, like 448, or I could do 384 resolution models for Deepface Live. But the idea, of course, with this will be to see how much faster it can do what this was doing. So now that I've explained all of that, hopefully that made some sense. This is like a 4080 Super versus a 5090. This should be much faster. The model I was just training was giving about 1100 milliseconds per iteration. Hopefully this would be like maybe 750, 800. That'd be interesting. So let's get it installed and see if it doesn't explode. Let's see if it has the correct number of ROPs, because apparently these things have a tendency to catch on fire and or don't have the proper hardware specifications. That'll be interesting. Maybe 1 minute, we'll hook it up, we'll find out. Okay, so I've got it in the system, but so I'm not able to use that kickstand that I was talking about. Like, basically, most cases it would be closer to the ground. You'd be able to like put this on the floor somewhere. This is magnetized, by the way, which is kind of neat. I didn't know that about it. But the way this case is laid out, like that shelf is too close to the card, so I can't stand it on that. You know, like it's just too tall of a piece of material. It's still got to jam into the card. I think you'd probably want to put it somewhere like right there for a little stability, or maybe on the end of the card somewhere. But again, I don't have anywhere to do that with that shelf, so I'll just have to deal with it as it is for now. I might have something around here I can use to shore that up. As far as the way my board is laid out, I probably could connect the RGB connector down to one of these 2 RGB headers, but I am going to see if it can just run off of Zotac software. I don't really want to connect that wire there. I just think that that's a bad spot for that. Now, for connecting this, what I want to do, and what I would recommend that you do, if you acquire such a card, is either, there's 2 options. A, some power supplies now have a built-in ATX 3.0 power connector, which means on the power supply it actually has a connection like this, and then on the GPU at the other end has the same connection, and you do it all over a single cable. This particular power supply in this machine does not have that. I do have one upstairs, but it's only a 1,000-watt supply. I don't think it's sufficient to do this, so I'm not going to use it. Plus, I don't want to mess with it. That's the system that has the AMD card in it. I don't want to mess with that right now. And I do want to use this in my living room for the aforementioned reason, because it has HDMI. So I don't really want to mess with the other computer. I want to use it on this one. So what you have to do, like I say, is convert 4 of these 8-pin PCI Express power connections into our single connection and then plug it into your card. So I would suggest using 4 dedicated power lines. Don't use, so some of these have a splitter on them, right? So like you see, this has 8, this has 8, but it's coming from a single power line back to the power supply. Bad. You only want to use one of the 2, because when you start doing this, it's like splitting the wattage and the amperage over, 2 different connections coming from one line. It just seems like it's better if you it's called load balancing, and I don't actually even know for sure how much it benefits splitting it, because it's all going to go into one connection anyway with our four-way to 1 adapter. Back in the day when GPUs had, it had like 3 or 4 of these connections right on the card. You would plug in one, you would take another connection and plug in the next one, plug in the next one, etc., until your your card was powered up. That load balanced the card. AMD always had problems with amperage issues if you didn't load balance it. Quite often for like the old what is it called, the R9 Fury series, for example, it seems like it always had issues like with aberrant behavior or power issues with the system if you didn't load balance the card. So I tend to do that anyway. It's just an old practice. I think it's still a good practice. So I connect an individual power line to each one of these, not using like the splitter to one and then the other end of the splitter to another one. I want it connected 1 to 1 and then hook it up. So I'm going to do that. We'll plug this in and we'll see if it powers up successfully. If it does that, then I'll be able to go ahead and play with getting drivers done and so forth and continue on from within Windows. So give me one moment, we'll play with it. Okay, so you can see I've got, again, a dedicated line to each of our 4-way splitter connections, which is now connected to the GPU on the 12-pin ATX 3.0 power connection. And like I say, each one should be able to deliver enough power that the whole card can get the necessary 575 watts. I think maybe some of it, like I say, goes across the PCI Express connection. I'm not sure how they set this thing up to distribute its power, but ultimately that is kind of what it should look like. One reason it's nice to have, again, a power supply that is compliant with ATX 3.0 and can run a single line to it, this has some weight to it, and it's like putting stress on that GPU connection all the time. It's just hanging there. It's probably good to tie it off somewhere if you can do that. I'm not sure how I'm going to set that up, so maybe I'll screw with that, maybe I won't. But a good practice would be to kind of tie this off with some zip ties and maybe try to shore it up or connect it somewhere so it's not moving around a lot, and it alleviates some of the stress on that connection. Because again, if these connections are prone to be a fire hazard, it's probably a good idea to not put any undue stress on them where you don't have to. So anyways, you can see it is connected. I do have some, like I say, RGB connections. I did mention that. All right, so I do have the RGB connections. I'm not going to mess with them right now. I'm hoping that this will run off the Firestorm software and I can just light it up and we can see how it looks. So give me one moment here. I'm going to go ahead and see if it powers up successfully without, letting itself on fire. Give me one moment. Alrighty, it's hooked up. See what happens, huh? Something's... Okay. Oh! Pretty. That mirror is nice. See what it does, huh? Next stop is hopefully it posts. Sure what it's doing. Oh! That's good. Alrighty, give me a moment here. I'm going to go ahead and play with installing new drivers. I'm probably going to run through display driver uninstaller and take out any, of the old GPU drivers from sorry, my headset decided that it wanted to alert me that it was connecting to my desktop too, so hopefully I didn't mess with the audio. But anyways, I'm going to go ahead and, like I say, install the new drivers. Sounds like the audio is working because I had HDMI, that only does audio over HDMI. So that sounds like everything is at least kind of working already. But give me a minute. I'm going to go ahead and play with that, get the drivers installed, install the Firestorm program, and then continue from there. Just give me a minute. Okay, so I've got the Zotac Firestorm program installed after installing the drivers. And they do have some different, hold on, this is kind of going to be awkward to do with the phone. I would just use my screen capture, but then you won't be able to see the card. I don't know how you can even read this. It's not done well, whatever. So they have all these effects. They have some standard effects, glide, prism, bokeh, beacon, fusion, tandem, tidal. I think you can pick kind of like a range of colors to go between. Currently it's just sitting on default, but if I like glide, for example, it'll start doing something there. Bokeh. I don't know if that's much different, honestly. Try changing the color. Yeah, it should be blue now. Okay. Red. Yeah, kind of red. Prism. And you can change the speed and the brightness. Well, the brightness apparently is whatever it does, but you can change how fast it does it, so that's cool. Standard effects like static lighting. Let's see, yeah, kind of brighten it. Again, change it to blue, change it to green, greenish, there you go. Breathing effect. There you go. So you get the idea, there's nothing really, mind-blowing going on here. Most GPUs have some kind of RGB lighting option that you can control with whatever their own, software is. That seems to be the case here. So this is the Firestorm interface. I've never used this program before because, like I said, I haven't really owned that many Zotac products, but you do have a status, fans, performance. So it reads like all your core clocks. You've got your GPU core, your memory core, GPU voltage, GPU temperature, which idling at 40 isn't too bad. I can obviously, the fans are on auto, which seems to be at basically 0%. So I will set them on manual. I'm going to put them to like 62. I don't know if you can link them. Seems like you can usually link them. You can kind of hear it picking up, but not much. Let me save that. Hopefully that's saving, I don't know. Where's the temperature at again? Temperature's dropped down to 37, so that's pretty quickly having the desired effect. You can set some fan curves or some sort of overclocking settings and so forth as you'd expect. Like I say, you got all your different lighting. You can do like one zone. You can shut off one thing, turn on just the sidebar, or just mess with the infinity mirror. And they do have like that cable we mentioned. There is a sync lighting via motherboard header. So if you enable this up here, then it would run the lighting off of whatever motherboard software you have. So I have, Asus board. I forget what the heck they call theirs now. It's like the Armory Crate, I think is the name of the software. But Asus has something. MSI has Mystic Light. Gigabyte has their own version, which I forget the name of that because I haven't used it forever. But basically, every motherboard manufacturer has their own RGB lighting software suite, and this would allow you to control the GPU lighting so it synchronizes with whatever motherboard lighting you might have. So if you have some kind of theme going on, you can kind of get it all synchronized together. But you can see that that is working successfully. So the next thing I'm going to do is switch to recording probably with OBS and see if we can find maybe a couple things to test. I do want to see if DeepFace Lab works, which should. So let's see if we can get something to work here. Give me one moment. All right, so I did get DeepFace Lab to at least start running on it, which was largely what, like I say, this machine is still intended to do this. Holy shit, this card uses a lot of power, which we knew it was going to, but you can see the board power draw right here. It's anywhere from like 540 up over 600 watts, which means it's utilizing probably the borderline, if not the entire ATX 3.0 power, 650, 670 watts. Wow. So it's using the entirety of that power line, and it's pulling whatever it can over the PCI Express power connection. And that's what it's did. That is nuts. Goodness gracious. But for some reason, which these numbers probably won't mean anything to anybody watching this, but it's actually getting a slower speed than what I'm used to. And yeah, right now I'm recording, so it's actually even a little bit worse because this is taxing the system pretty hard. But normally, the system will use, or was getting about 1200 milliseconds per iteration of training. So you can see this number that's ticking by. Every time it makes a tick, an iteration of training has happened. And I was getting, like I say, about 1200 milliseconds. Now I'm getting I was getting 1400 when I wasn't recording. So it's slower currently than my previous generation kind of mid-upper range card versus the flagship card. On the plus side, so clearly the problem with this isn't the card really. It's the fact that DeepFace Lab uses outdated software at this point. It uses what's called a TensorFlow GPU, and that runs off of, like, it was designed to run on like CUDA version like 11.8 or something, and now the new cards, the 50s, 90s, use CUDA 12.8. And to fiddle around with that, I've gone in and I've got like my CUDA libraries here, and I downloaded and installed CUDA 12.8 onto my C drive. I don't have that folder open right now, but I copied over the new libraries, the new dynamic link libraries, and then I renamed them to whatever the old libraries were named, so that DeepFace Lab can at least address those libraries and use them for DeepFace Lab training. Otherwise, it won't even detect the GPU. If you don't do that, it doesn't know what the newer cards are. So at least it's using it, and it does run. But my God, the power draw on this thing. Guys, I don't even know if I want to keep this card for this purpose. For gaming, I guess. But the power draw on that is astronomical compared to what, again, I'm used to like 220, 240. Even when I was running my 4090s that I've had, they used like 450, 475 watts, maybe most of the time. So it's substantially on that. And the 4090s got quite a bit better speed than this too. Although, again, I couldn't even trade this model on a 4090 because it didn't have enough video memory. So this is a 448 resolution. These are some of the specifications for anybody who knows what this stuff means. But yeah, that is a serious power bill increase. And currently the performance is actually worse. Like I say, it seems to work. Like this is Angelina Jolie being trained on Conan the Barbarian's, or excuse me, Conan the Destroyer, the Evil Queen. So it functions, but until they, hopefully one of the developers that did the quote-unquote MVE fork of DeepFace Lab will figure out how to improve the performance of this, because currently I wouldn't use it for this. It's just too much power draw. The performance is actually worse. I could have bought, well, I mean, for this price, I could have gotten pretty close to getting yet another one of those RTX 5000 ADAs. As much as people seem to be willing to pay for these cards right now, I might even be able to sell it or trade it and get like an RTX 6000 ADA and have 48 gigs of video memory and run that on 250 watts and probably get better performance. Actually, yeah, I know to get better performance than this, because the 5000 ADA is faster than this currently. The 6000 ADA is like a 4090 Ti if that existed, because they have more CUDA cores than the 4090, and it has, again, more memory, twice the memory. They have 48 gigs. They're like a $6,000 GPU. But if somebody wanted to trade me one for this, but I think currently, like I say, it's obviously not working right. The only reason it works at all is because I fiddled around with swapping in those dynamic link libraries and renaming them, but, not really working in an ideal fashion. You can kind of see the GPU voltage, the core clocks it's getting to. The temperature is actually getting, I don't say like that's really high, but it's pretty kind of high. Let me turn this up to 70-ish range. Apparently you don't have to apply this. As soon as you move it, it just does it. Now that's getting quite a bit louder. I don't know if you guys can hear that very well, but that is noticeably loud. Louder. Let me see if that has any effect on that temperature now real quick. Sorry, it keeps minimizing the application. Performance temperature is still in the 70s. And it's fairly cool in here right now. It's like 71 in here right now. So it's, not that I'm running AC or anything. It's still wintry weather around here somewhat. Today was like in the mid 60s, but the temperature is all over the place. I don't know how accurate that is. Clocks, everything's kind of at stock too. Like, I think it would be difficult to overclock this thing. I'd kind of be curious to see what some of the other, like some of the other 5090s do in terms of their temperatures and how well their cooling is helping them out. I think I showed you guys, but the ROPs are correct. I got the 176 because supposedly the defective cards have 168. So it does have the correct number of ROPs. Everything else is correct. I have the latest game ready driver that I've installed. It is running at Gen 5, but it is running at X8 because I have too many NVMe drives installed in the system, so they're using up the PCI Express lanes. I could try putting it in with my Threadripper if I wanted to get the full 16 lanes. I don't think it would matter much. I've been running, again, the other cards that I run on here were also running at 8X, and they were getting better performance in DeepFace Lab. So it's not really the lanes that are the issue here. But if somebody noticed that and was like, hey, that's your problem, it's not. From my understanding, it's about a 1% difference between 8X and 16X. For gaming benchmarks and so forth, yeah, I'd like it to run at 16. I just have, like I say, I don't have enough lanes to run all the I'd like to get like one big, like 8 terabyte NVMe drive or something, but they're stupid expensive. And if it failed, you'd lose a lot of data. So somewhat better to just have a few drives. But okay, I think I'm going to call the video here. I know probably people want to see gaming tests. I'll do those separately in other videos just because I've already been recording for a while and I'm recording at like 1080p, 30 frames a second. Games will not look good and it won't translate well to that. So I'll do those separately. But I'm going to kill this. And let's see how quick the temperature falls off. Give it a second here. And this should close out. See, it's saving. So the temperature's dropped off now into the mid-50s. Just kind of want to see how fast the temperature drops on it. Still 51. Kind of not ultra impressed with how fast this thing cools down either. I mean, the core clock is rapidly dropping off into nothing. I mean, it dropped 20 degrees pretty fast. It's not like it's overheating or anything either, but gosh, for that much power draw, I would like more. Then again, once the guys that, like, there's a couple guys from the Discord, the Deepfake Discord channels that will probably be fiddling around with this. They have what's called a PyTorch version of DeepFace Lab that probably would work with this out of the box and I wouldn't have to tweak it. That program doesn't have some of the features that the base version of DeepFace Lab has, but I probably will at least test this in the PyTorch version and see, if it's pretty fast in that. But that said, I think I am going to call the video here, guys. I appreciate everybody watching. I haven't done a hardware box unboxing and testing video in a while. Hope everybody liked it. If you have any requests for anything specific to be tested in the comment section, please let me know. Otherwise, like I say, I do have some games I can test with it. I'm not as big of a gamer as I used to be, but I have some stuff on Steam I can install. I don't have anything like Kingdom Come Deliverance 2 or anything. There's other channels that have tested some of those games. Like Digital Dreams did Kingdom Come Deliverance 2 at like 8K. I do want to try Witcher 3 and see how that runs, like with their Transformer model for DLSS 4, and see how some games work. Cyberpunk, I want to screw around with that, of course. I want to try some of the mods for that and see how this can run those. So maybe Skyrim again. I haven't played that forever. So appreciate everybody watching the channel. If you like the video, give it a thumbs up. Subscribe to the channel, please. And maybe share the video with your friends if you think it was valuable. Everybody have a great night. I will talk to you guys again here in the near future. Take care.